Good morning, students. Myself, Badi Alekhyya, Assistant Professor, Department of Artificial Intelligence and Machine Learning, RMD Engineering College. Today, we are going to see the brief introduction regarding supervised learning algorithms in machine learning. So, we are already aware of under machine learning we have three types of machine learnings. One is supervised, another one is unsupervised, and the third one is reinforcement. Mainly we are going to study different types of machine learning techniques in supervised and unsupervised. The keywords what we remembered under supervised is it deals with both classification and regression techniques. So the terminologies deal with unsupervised learnings are clustering. So what are the topics we discussed under our previous classes, PCM, LC, that K means clustering, that and all comes under unsupervised learning. This means purely based on cluster oriented. Now this is comes under unsupervised. So based on labeling data, if you are going to work now, that comes under supervised learning. So just be aware of that. What are the different types of classification algorithms under supervised? We have different types of classification algorithms under supervised learning: naive based decision trees, random forest, logistic regression, KNN, support vector, ANN. Like the different types of algorithms are available under classification. Regression, we have linear, polynomial, logistics. Different types of regressions are there. These are all the applications. The classification algorithms have a lot of real-time applications like email spam and malware filtering, online fraud detections, health case risk predictions. At prediction process, we are going to prediction detection process. We are using classification. So trend analysis, financials, so numerical information. So it means environmental data, finance department trend lines, that market based analysis. The not market based analysis, that means if you are going to predict something on the predicted the values something based on the numerical or continuous values, now we are going to follow regression techniques. So today so in another videos we have discussed that in which way we are going to work with unsupervised learning algorithms, but today's class we are discuss that how we are going to use the algorithms of supervised learning techniques by using R tool. So I am going to show some of the codes related how in the previous classes we discussed how to work with Colab, but in this video I am going to show some of the sample codes regarding how to implement this machine learning supervised learning algorithms under R tool environment. So under supervised algorithms, we are aware of that under regression we have a first algorithm as linear regression. Is also one type of statistical model which shows the relationship between the dependent and one or more independent variables. What is the meaning of here is we have in a database we are going to give lot of attributes. Just for your understanding, I am giving one example here. You are going to consider a three class variables. The three class variables is I am going to give the name, I am going to give the age, I am going to give the designation. So name, age, designation I am going to use. I am going to find out the salary of the person now. So first of all here the name, age and designation comes under the independent variables. These independent variables, the designation and the name and the age of the person, will decide at the salary of the person. Now their salary will comes under dependent variables. So linear regression is applicable to solve that type of problems in the real-time environment. I again I repeat it, what is dependent and independent variable, then only it will be easy for you people to understand what's the concept I am going to discuss in the upcoming slides. So here independent variable is nothing but what are the attributes in your data sets you are giving. That attributes like name, age and designation, you are going to predict the salary of a person. Now these name, age and designation only will decide at the salary of the person. The that attributes we are call it as these name, age, and designation comes under independent variables. That salary will comes under dependent variables. So this linear regression will provides the relationship between both dependent variable and one or more independent variable. So we have different types of regression: linear, logistic, and polynomial. In this section I am going to show what is linear regression. If you observe that x values, I am going to here before going to understand the linear model, we are going to use a slope formula that you are aware of, that the slope intercept formula y equal to mx plus c. So here y is a dependent variable and x is a independent variable, and how we are going to correlate it to find out the prediction by using this dependent and independent variable. Imagine that I am passing some values under x. So here x is a independent variable. I am passing the values under y. Y is the output. So simply we called it as x is the input and y is the output. I am going to plot one graph called between the x and y. I am going to check whether y is linearly dependent on x. So for that I am setting the data frames. I am passing some values under the x. If I am going to give a new input under x, whether y will predict the correct output or not, I am going to explain in this example. So again I will repeat it. Here I am giving some values for the x. This is input. Some values for the y. This is output. I am going to check that the values is y is linearly dependent on x. So here I am training the data. So we are aware of that in the initial classes is that before going to fit any model, we have to train the data, then only we are going to move for the validation or testing for the predictions. So if you observe here, I am passing some values 151, 170, 138. I am passing some values as input, and I am going to give the corresponding values. If 151 now, what is the output? 170 now, what is the output? If 138 now, what is the output? Like that, the corresponding values I mentioned here. So my model, my linear regression algorithm has to find out if I am giving a new input 156, it is correctly predicting the result of y. So let us check how it is going to validate by using the slope intercept values. How my model will predict the values after training. When I am going to test the model, how it is going to correctly predict it. Let us discuss in the next slide. So just for your understanding, so dependent variables, for example, in the previous program, so I am giving height in centimeters, weight in kgs. So here the x is the x axis I am considering height, and y axis I am going to considering the weight. I am expecting you understand that here height is a independent variable and weight is a dependent variable what we are going to predict. If I am giving after applying the linear regression model, if I am testing the model, if I am giving the height, that linear regression model has to correctly identify the weight of the person. So here dependent is y and independent is x. You observe here x I am passing the values, different types of values 151, 170, 130, like that I am passing different types of values, and y also I am passing different types of values. I am going to find out the summation of these things, and after that I am going to find out that there is a what's the prediction values x minus x bar and y minus y bar we are going to consider, and we are after applying the formulas we are going to calculate x minus x bar whole square, and same like that. What's the things needed for my formula? I am going to calculate like this based on the x and y values. If you observed here, you are going to find out the slope value. There is a slope value. That slope value we are identified by using this formula: x minus x bar y minus y bar by x minus x bar whole square. So after applying this formula, we are going to get the slope values 0.54863747. Sorry, y equal to ms plus c. So now we know the value of y. For example, if I am knowing the value of y bar is 56.875, m value we calculated, and we substituted the value of x bar plus some constant value. So here we are going to uh, find out the constant value. So after applying all these things, if you are performing the operation, the constant value will be, for if you observe that what is the constant value, it is generated this one. So this is the c value. Now we are going to substitute y equal to mx plus c. X they are giving 1.156. Now I am going to predict that whether the given model is currently identified the values. We know the value of x. We know they are giving the input as 156. They asked to predict the value of y by using linear regression model. So if I am going to substitute the value of m, what is my input? 156. So and what is the c value? If I substitute that value, what is the weight of that particular person? It's in the range. That means here we are not going to find out the exact value, the nearest value. The nearest value, if the height of the person is 156, the weight of the person is near to 57. If you observe here 151 is between the ranges of 50 only. So my model will correctly predicted the weight of the person. That means not accurate value, correctly predicted the height of a person, weight of a person based on the height. So in this way we are going to apply our linear regression model. So you are aware of the term. I already discussed that y is dependent, c is constant, m slope, in x is independent variable. Now see, I tell now none of the application of classification is email filtering, spam filtering, and if in your inbox, if there is any spam mails in the mail service provider, either it is a Gmail or Yahoo, the classifiers will post that messages to the classifier. The classifier will classify that is a mail which is moved to the inbox or the mail moved to the spam. That means the spam filtering. So after getting the mail in a inbox, it is going to check that by using the classifier, it is decided that whether we have to move that mail to the inbox or the spam box. So in that type of application we are using classification. So we have bias classification problem, same things, we are having n number of features, and output we are going to predict the with the variable y. So like that we are going to pass just the examples, real-time applications, how it is going to recognize the digit recognitions. This is one of the application for classifier. So in bias classifier, same thing, there's some bias claim is there. Probability functions we are using to classify whether the given data belongs to which class, either yes or no, or otherwise there is a probability of getting rain or not. The further type of scenarios, that the type of classification we are using bias classifier. So everybody know of that what is this bias rule. So in bias rules we are going to provide a number of features that will identify the prior probability. That will help to think how the features are generated by the class label. So here I am going to tell a model by using R code. So I am going to install I am going to install some packages in that. I am going to try same point. I am repeating again and again. I am reading the CSV file of train data and test train data. After completing the training, how my test data will evaluate the model by using the test data. How my model will be evaluated, we will discuss. So I am training with the label whether I am going to train the label play. We will whether they play or not levels in the tables. This is some lines of code which we are using under R tool implementation. So what's the algorithm I am using here is naive Bayes classifier. I am going to evaluate this model by testing data. So I am predicting after test data, my model will predict the data correctly or not. I will check by this predicate keyword. So I am going to explain that here whether based on whether I have to find out that whether the person will play or not. So if you observe that we have weather conditions of sunny, overcast, rainy is there. Repeatedly the same three scenarios will be repeated. We are going to consider how frequency table of weather and frequency table of overcast, rainy and sunny. So we have three categories: overcast, rainy and sunny. I am going to check that what is the frequency table of yes playing by based on weather conditions. If you observe for overcast, the frequency of playing is 4, and the rainy the frequency of playing is 2 and not playing is 3. Like that we calculated for sunny, and the grand total for not playing is 5 and per playing is 9. So now after designing the frequency table, I have to design the likelihood table, because likelihood value only will predicted likelihood value will be used to calculate to apply in the Bayes theorem, which will be helpful to predict the values. If you observed here, I am considering overcast, rainy, all these things. We have a total number of entries in the table. What are the total number of entries in the table? Here we have total number of 14. So 5 by 14. Out of 14, 5 are no, and out of 14, 9 are yes. There is a chance of play for 9 times, and there is a chance of play. There is no chance of play for 5 times among 14 entries. So we will calculate that thing, and we will solve using above discussion of posterior probability. If it is sunny, yes, na, what is the probability? We have sunny, yes, na, what is sunny, yes, we have 3, and the total number of yes condition is 9. So 3 divided by 9, 0.33. And for the same like that, no for no, total number of no is 5, and the total number of things we have to consider is 14. What is the value? 0.36. So for sunny, this is the likelihood value. This is the likelihood value P of sunny. This is the posterior probability. It's a probability value. So when we are going to calculate the posterior probability, we have to calculate both likelihood value and probability value. So the probability of value of P of sunny S is 0.33, and the probability value posterior probability value is 0.36 divided by P of sunny. What's the value of P of sunny? That value we have to substitute. For example, here the value for P of sunny comma S is 0.33, and the posterior probability value is 0.264 divided by, and P of sunny value we already calculated, that is 0.36. After, what is the value of that thing now? 0.60. So which having the highest higher probability. So same like that, players will play if weather is sunny. Is this statement is correct or not? Now we are going to calculate the yes. If it is having the highest probability, there is a chance. If the sunny is there, na, there is a highest chance of playing. If the weather condition is sunny, the probability of playing is high. So it's a mathematical representation how this Bayes theorem will predict the values based on the past scenarios. So same like that, we have k nearest neighbors. It's a simple algorithm which uses entire data in its training phase. So here k represents the number of instances and the data which have with the most similar values which is helpful for the final return of the prediction. So we will see. So if the k is 3 now, we are going to consider the 3 nearest points of this algorithm. So here blue dots will represent the data points belongs to class A, and brown points will represent the yellow points will represent the data points belongs to class B. So height and weight is the same example what we consider under linear regression. Height and weight I am giving. If I am going to find out the size of the shirt, how I am going to implement this algorithm. So these are the data I am passed for the k nearest neighbors. If you observe that here we are using a formula called Euclidean distance. So here point 1 comma 1 and point P2 5 comma 4. Now how we are going to calculate the distance? Euclidean distance problems, everybody knows that we have a formula x2 minus x1 whole square plus y2 minus square root of x2 minus x1 whole square plus y2 minus y1 whole square. If you observe that thing, now I am going to check my prediction model. New customer named Raja has height 161 centimeter and weight 61 kg. So I am going to find out that which type of thing will be suitable for that point. That we are aware of that. What is the formula? 161 centimeters. But in my data, near to 161 centimeters. Less than 160 centimeters is 160, less than 161 centimeters is 2 entries is there, more than 3 entries is there, and greater than 160 centimeters 2 entries is there. So the distance between, we have to calculate the Euclidean distance between the points we have to consider. So and after that so nearest points, what are the nearest points we have to consider? If you observe here now, 160 161 we have to consider, 160 we have to consider. We have a height in centimeters is there. Here first observation and new observation is as follows. So first observation is they are giving that 160 centimeters and weight is 61 kgs. If I consider, so just like for all things you have to calculate and you have to find out that which one is the nearest points. So if I am going to calculate with 158, my given input is 161, and then in my table entry first entry is 158 square root of x2 minus x1 whole square plus my weight is 61 kg, predicted value is 61, and the weight for the corresponding height is 58. Again the formula we are going to substitute. Like that I am going to train the data by using our things. That I am going to pass height in this row, that is x values, and weight, the corresponding weights I am going to pass in the trained data. The trained data will check that height and weight of the person. Here it's my test data. So these are all training data. In this loop I am giving my training data. These are my test data. So if my height is 160 meters and if my weight is, sorry spelling mistake, if my weight is 61, what is the size preferred to my test data. So this test, for this test data, I am going to find out the size, whether it is M or L. So if I am going to factor the data, try and test things, it has to print the result. In this way, so if you observe this, if you observe these things, the nearest things, if after applying this formula, I am going to give the ranking that which one are the nearest things. Now I am providing the things, what is the among this thing. When I am calculating for all the things, the applying the same formula for all the heights and weights in the given data table, I am going to find out which are the nearest neighbors. Nearest neighbors, I am going to give the rank. So among these values, which one is the nearest less number of distance? Now, less distance is this 1.64. So I am going to give the rank is 1. Again, I am going to give for the next value. Like that, I am giving the rank, and I am going to check that which value is most near here. First rank is for 1.4. Therefore, the size of the shirt size for the person of height 161 centimeters and the weight 61 kgs is a medium. Like that, the k nearest neighbor algorithm will help us to calculate the predict the values in classification models. uh, okay students, I think show some of the concepts in problematic in mathematical way you understanding regarding supervised learning algorithms. I summarize that first we discussed that what is linear regression, what is the mathematical notation for linear regression, and then what is classification. Under that, what are the applications of classification, and then we discuss about naive Bayes classifier, how it is implemented the data for the weather prediction. We discuss with one example, and after that we are discussed KNN algorithm, how it is going to predict the values based on trained data. We discussed that how it will be evaluated. So that's all for the today's sections. Just we see some of the classification algorithms and how it is mathematically implemented and how it mathematically implemented and predicted the values at the receiver end. That's all for the today's sections. In the next video I will meet with the unsupervised learning techniques. Thank you students.